Good morning, dear students. This is Deepak Yadav. Welcome in your physics class. As we were continuing our chapter 2 in physics, and we were seeing dimensional analysis, applications of dimensional analysis. Today we will see and discuss about the third application of dimensional analysis. It is a very important application we have to study about in physics, and under this section we have to discuss how we can deduce a relationship among various physical quantities. That means after discussion of this topic you will be able to find the physical equations or physical relations, physical formulae, when you are knowing the various factors on which a physical quantity depends. It will be provided in the question that a given physical quantity is depending upon how many other physical quantities. For example, if you consider the kinetic energy, then you will be given that the kinetic energy is depending upon mass and velocity of the body, and that's why you can use the dimensional concepts you have read in deriving the formula of kinetic energy, that is k is equals to half mv square. Let's see how it is possible. So by making use of principle of homogeneity of dimensions, we can derive the expression for a physical quantity if we know the various factors on which that particular physical quantity depends. Point to be noted: any physical quantity depends upon other physical quantities. If you are knowing the factors on which the physical quantity depends, you can derive the formula for that physical quantity using the concept of dimensions, basically the principle of homogeneity of dimension. Let me repeat: homogeneity of dimensions states that in a physical equation, the dimensions of LHS must be equal to the dimensions of each term in the RHS. Again, I am repeating: the principle of homogeneity of dimensions states that in a physical equation, the dimensions of each term in the LHS is equal to dimensions of each term on the RHS. Let's continue. So, to derive the relationship among various physical quantities, that is, to derive any physical formula, we must know the various factors on which a physical quantity depends. Let us take an example. Let us derive an expression for kinetic energy of a body of mass m and moving with velocity v. So as we know, kinetic energy Ek is equals to half mv square. Ek or k, you can write simply k or Ek, kinetic energy. So we will derive it by using dimensions. Let us consider, we have to consider that Ek is directly proportional to m to the power a and v to the power b. M to the power a and v to the power b, that is, dimensions of m is a and dimensions of v is b here. And since it is given that kinetic energy is depending upon mass and velocity of the body, so you have to consider like this. And instead of this proportionality sign, you have to put a constant here with equal to sign. Okay, so Ek is equals to a constant k into m to the power a into b to the power b, where k is a dimensionless constant. It has no dimension, dear students. So writing the dimensions of various quantities, physical quantities, in equation 1, in both for LHS and RHS, we have dimensions of Ek is equals to dimensions of m to the power a and dimensions of v to the power b. Dimension of Ek is equals to dimension of m to the power a, v to the dimensions of v to the power b, as k K has no dimension, it is dimensionless constant. So writing the dimensions, Ek has the dimension of energy ml2 t to the power minus 2, and mass has the dimension m, so m to the power a, and V has dimension L to meter per second, that means LT to the power minus 1 to the power B. So simplifying the RHS and LHS, you will get ml2 t to the power minus 2 in LHS equals to m to the power a, L to the power b, b here, this is L to the power b, and t to the power minus b. So according to principle of homogeneity of dimensions, equating the powers in LHS and RHS, you will get the value of a is 1 here for m, so a is equals to 1, and b is equals to 2, b is equals to 2. Hence the expression for kinetic energy is Ek is equals to k m to the power 1 v square, because we had taken E is equals to, initially Ek is equals to k m to the power a and v to the power b. Since a comes out to be 1 and b comes out to be 2, so the formula will be Ek is equals to k m to the power 1 and v to the power 2. And considering the value of constant to be half, the value of kinetic energy becomes half mv square. Okay, dear students, next let's take a question. By the use of dimensions, derive an expression for centripetal force acting on a particle of mass m moving with velocity v in a circle of radius r. You have to take the constant of proportionality to be 1. Okay, so let's see. The solution will be like this. Let us consider that the centrifugal force depends upon the mass, velocity and radius as follows. F is proportional to m to the power a, v to the power b and r to the power c. So removing the proportionality sign, F is equals to k m to the power a, v to the power b and r to the power c, and writing dimensions on both sides LHS and RHS. LHS is force, so ml to the power minus 2, and RHS, in the RHS k is dimensionless constant, so its dimension should not be written. So the dimension of mass is m to the power a, so v has the dimension L to the power Lt to the power minus 1 whole to the power b, and for r to the power c you have to write length to the power c. After simplification, in the RHS you will get m to the power a, L to the power b, t to the power minus b and L to the power c, and adding the powers m to the power a, L to the power b plus c, t to the power minus b. Okay, dear students, and then equating the powers, corresponding powers, using the principle of homogeneity of dimensions, you will get a is equals to 1 and b plus c is equals to 1 and minus b is equals to minus 2. From here you will get b is equals to 2. On substituting 2 here in equation b plus c is equals to 1, you will get c is equals to minus 1. You will get c is equals to minus 1 like this, and a is already 1, so c is equals to minus 1 and b is equals to 2. On putting the values, centripetal force F is equals to k m to the power a, v to the power b and r to the power c. So putting the values of a, b and c, we have m to the power 1, v to the power 2 and r to the power minus 1. Putting the constant value to be 1 as given in the question, so it is given in the question, the final value becomes for the centripetal force F is equals to mv square upon r. Let's take a question from NCERT book, your NCERT textbook. Consider a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Suppose that the period of oscillation of simple pendulum depends upon the following factors. The factors are the mass of the bob, the length of the pendulum, the acceleration due to gravity at that place. So we have to derive the expression for its time period. Derive the expression for the time period using the method of dimensions. you have to use the method of dimensions, and you have to take the constant value to be 2 pi. You have to take the constant value to be 2 pi. Let's solve it. So using the dimensions, using the dimensional concepts, t is proportional to m to the power a, l to the power b, g to the power c, as given in the question. Because m is the mass, the time period depends upon the mass of the bob, length of the string, and acceleration due to gravity at a particular place. So removing the proportionality sign, we will put here equality along with the proportionality constant k, where k is dimensionless, and then writing the dimensions of various physical quantities. Let's see the dimensions of various physical quantities in equation 1. T has dimension t, mass has dimension m, length has dimension l, k is dimensionless, and g, since it is acceleration meter per second square, so it has dimension l t to the power minus 2. And on substituting these values in the above equation, in this equation, putting all the dimensions here in equation 1, you will get an equation like this. T is equals to t for t, m to the power a, l to the power b, and acceleration, that means g to the power c, that means l t to the power minus 2 to the power c. And on solving, here l to the power b and l to the power c, here adding the powers l to the power b plus c and t to the power minus 2c on opening the brackets. From the principle of homogeneity of dimensions, we will get, since there is no mass in the LHS, so m to the power 0 here, so a is equals to 0, and b plus c, l is absent here, the l to the power 0, so b plus c is 0, and to minus 2c is equals to 1, because t has power 1 here in the LHS. So on solving, you will get a is equals to 0, and since here you will get c is equals to minus half from here, and on putting c here in second equation, b plus c equals to 0, b is equals to half. The time period of simple pendulum is thus given by t is equals to k m to the power 0, l to the power half, and g to the power minus half. As we have seen that we have taken t is equals to k m to the power a, l to the power b, and g to the power c, or we have find the value of a to be 0, value of b to be half, and value of c to be minus half. And in this way, as given in the question, the proportionality constant is 2 pi, the final value is 2 pi root under L by G. Minus half means G goes to the denominator, and plus half, L comes to the L is put in the numerator, and half powers means under root. Now the third question is, the velocity of sound waves v through a medium may be assumed to depend upon the following factors. The factors are the density of medium d, the modulus of elasticity E. I have told you, dear students, modulus of elasticity has the same dimension as that of pressure or stress. Modulus of elasticity has same dimension as that of pressure or stress. Density is L to the density is kg per meter cube, so it has m by L cube. Density has dimension m by L cube. So we have to deduce by the method of dimensions the formula for the velocity of sound, taking dimensional constant to be 1. So let us take v is equals to k density to the power a and modulus of elasticity to the power b. Using the dimensions, writing dimensions on both sides, this is velocity L to the power minus 1, and density has the dimension mass per unit volume, that means m by L cube, ml to the power minus 3, and modulus of elasticity has the dimension same as pressure or stress, it has the dimension ml minus 1 t to the power minus 2. So substituting all the dimensions in the above equation, you will get a new equation like this. On equating the powers, on solving, simplifying, opening the brackets, you will get the powers like this. and on equating the powers of LHS and RHS according to the principle of homogeneity of dimension, since m is absent here, so m to the power 0, a plus b का value हो गया 0, and L has the power 1 here in the LHS, so RHS equating with RHS minus 3a minus b is equals to 1, and in the RHS minus 2b power has of t is equals to minus 2b, and in LHS t has power minus 1, so equating both the powers minus 2b equals to minus 1, it will give you b is equals to half. Putting b in first equation, you will get a equals to minus half. Thus we are able to find both a and b, and in this way the velocity of sound becomes v is equals to k d to the power minus half. As the value of a is 1, we have taken d to the power a and elasticity to the power b, so the value becomes v is equals to k d to the power minus half e to the power half, d goes in the denominator, and taking the value of k to be 1 as given in the question, so we can write like this, and the velocity will be under root e by d. This is the expression of speed of sound in medium. Now the fourth question is, a planet moves around the sun in nearly circular orbit. Its period of rotation revolution t depends upon. The planet moves around the sun in nearly circular orbit. It is our assumption that the planet is moving in circular orbit around the sun. So, and its time period of revolution t depends upon radius of orbit, mass m of the sun, and the gravitational constant g. We have to show dimensionally that t square is directly proportional to the cube of the radius of the orbit. Taking the proportionality constant k is equals to 2 pi, write the expression for t. We have to write the expression for t using the dimensions. So similarly we have to take an expression t directly proportional to radius to the power a, mass of sun to the power b, and gravitational constant to the power c, because the time period depends upon these three factors. So taking proportionality constant k in place of proportional sign, we will get t equals to k r to the power a, m to the power b, g to the power c, where k is dimensionless constant. So writing the dimensions of various quantities, t has the dimension t, r has the dimension of length, mass has the dimension of mass m, and gravitational constant we have seen. How can we find the dimension of a gravitational constant? F equals to g m1 m2 upon r square. From here you will get g equals to fr square divided by m1 m2. That means the dimension of force is ml t minus 2, and r square has dimension l square. This is l into l. So you will get m into m. So you will get the dimensions for g is this, and the final dimension is this, because here this is the dimension of force, this is r square, this is m1 into m2, m square. So finally you will get m to the power minus 1 l cube t to the power minus 2. Substituting all the dimensional values in the above equation, you will get the equation t is equals to l to the power a, m to the power b, and g to the power c. That means m to the power minus 1, l to the power 3, t to the power minus 2c. And equating the powers, solving the powers on the RHS, we have the equation like this, and using the principle of homogeneity of dimensions, we get, as there is no m in the LHS, so b minus c to the m is 0 here, so b minus c is 0, and l is also l to the power 0 in the LHS, so m plus 3c equals to 0, and minus 2c equals to 1. From here c equals to minus half. If you put here in second equation the value of c, you will get a equals to 3 by 2, and if you put value of c here, you will get b equals to minus half. And on substituting these values in the above equation, t is proportional to r to the power 3 by 2, m to the power minus half, and g to the power minus half. This will give you t proportional to r cube, since half becomes under root 3 by 2, that means 3 into half, and this goes in denominator, this goes in denominator due to minus sign, so the expression will be like this: t proportional to under root r cube by ng, and t is equals to a proportionality constant k under root r cube by gm. Now t is equals to 2 pi root under r cube by mg. Clearly t is directly proportional to under root r cube, so squaring we get t square is directly proportional to r cube. This is Kepler's third law. Now we have already have t equals to 2 pi root under r cube by gm. As per asked in the question, we have solved it. Now let's take another example in form of question number 5. Derive by the method of dimensions an expression for the volume of liquid flowing out per second through a narrow pipe. Assume that rate of flow of liquid depends upon the coefficient of viscosity of liquid, the radius r of the pipe, and the pressure gradient P by L along the pipe. We have to take the proportionality constant to be pi by 8. So dear students, let us see that the rate of flow of liquid, that means volume flowing per second, V by T. This is V by T, volume by time. What will be the dimension? This is L cube upon T. Volume has the dimension L cube and time has the dimension T. So the rate of the above equation can be written as, this is coefficient of viscosity eta having the dimensions ml minus 1 t minus 1, we have seen and we will derive it. So the radius of pipe has the dimension L, and this is pressure gradient, pressure divided by distance or P by L. It will be the pressure has the dimension ml minus 2. Pressure has the dimension, pressure equals to force by area, so ml t minus 2 divided by L square. This gives you ml minus 1 t minus 2. So let's take the equation. V is equals to k eta r to the power a r to the power b, eta to the power a r to the power b, and pressure gradient, that means P by L to the power c. Please note, V is not volume here, this is volume per unit time. And note the velocity, it is the rate of flow, the rate of volume of liquid flowing through the pipe. This is volume by time. LHS is volume by time here, V. So writing the dimensions of different quantities, V has the dimension volume per unit time, that means L cube by T, that means L cube T to the power minus 1, and eta has the dimensions. You can calculate the value of eta to be dimensions of eta like this: m1 L to the power minus 1 T to the power minus 1. From this equation you can calculate it, and we have seen it earlier. Using this formula you can calculate it. Here dx is length and dv is velocity, f is force, and a is area. If you substitute all those values, you will get eta, dimension of eta to be m to the power 1, L to the power minus 1, and t to the power minus 1. Here radius has the dimension of length. This is pressure gradient. In the numerator we have written the pressure divided by length. This is m L to the power minus 2, t to the power minus 2. And on substituting all the dimensions in LHS and RHS both, we will get the values like this: L cube T to the power minus 1 in the LHS, and putting all the corresponding values and solving in the RHS, you will get m to the power a plus c, L to the power minus a plus b minus 2c, and t to the power minus a minus 2c. From the principle of homogeneity of dimensions, equating the corresponding powers, since m is absent here, m to the power 0, a plus c is equals to 0, and equating the powers of L, minus a plus b minus 2c equals to 3, and minus a minus 2c equals to minus 1. In this way, on solving, you will get a to the power minus 1, b to the power 4, and c to the power 1, and substituting all the corresponding values in the above equation and taking the proportionality constant to be pi by 8, we will get the expression for volume V equals to pi by 8 PR to the power 4 divided by eta L. So this is also known as Poiseuille's equation. Poiseuille's equation. This is famous Poiseuille's equation. Now we will see in short what are the limitations of dimensional analysis. इसकी कुछ खामियां हैं, उनको हमें देखनी है. फॉलोइंग्स आर द लिमिटेशंस ऑफ मेथड्स ऑफ डायमेंशंस. हम लोगों को सबसे पहले इसमें ये जो डायमेंशनल एनालिसिस हमने कवर किया, इसकी जो खामियां हैं वो कैसे उजागर होती हैं आप लोग देखें. द मेथड डज नॉट गिव एनी इंफॉर्मेशन अबाउट द डायमेंशनलेस कांस्टेंट के. वी आर क्वाइट अननोन विद द फैक्टर के इन every formula, and if we are not knowing, we are not given the value of k, then we have to carry out very many experiments. We have no idea about k, and we are uncertain about that. It fails when a physical quantity depends upon more than 3 physical quantities. It becomes complicated for more than 3 physical quantities if you are given a physical quantity to be depending upon more than 3 factors. It fails when physical quantity like s equals to ut plus half at square is the sum or difference. यहाँ पे आप लोग ने देखा कि जो भी डायमेंशंस हमने कैलकुलेट किया, जो भी फिजिकल क्वांटिटी का फॉर्मूला डिराइव किया, वो प्रोडक्ट फॉर्म में हमने लिया है. जैसे हमने लिया था काइनेटिक एनर्जी इज डायरेक्टली प्रोपोर्शनल टू m टू द पावर a v टू द पावर b. दिस इज इन प्रोडक्ट फॉर्म. इट इज नॉट इन द फॉर्म ऑफ सम और डिफरेंस. सो इन केस ऑफ सम और डिफरेंस, if you are asked to derive the formula, the method fails at that situation. And the fourth very important limitation is that it fails to derive relationship involving trigonometric, logarithmic or exponential function. The expression that involves trigonometry, logarithmic and exponential functions, and then it will become more complicated, and we generally fail to derive the physical formula. And sometimes it is difficult to identify the factors. कभी कभी क्या होता है कि हम लोगों को फैक्टर ही नहीं पता चलता है कि कोई क्वांटिटी किन किन फैक्टर्स पर डिपेंड करता है. एंड इफ़ वी आर नॉट सर्टेन टू डिटरमाइन ऑल द फैक्टर्स, देन वी आर नॉट एबल टू डिराइव द एक्यूरेट फार्मूला फॉर दैट फिजिकल क्वांटिटी. So the method becomes more complicated when dimensional constant like gravitational constant, G Planck's constant, etc. are involved. Okay, dear students, these were some limitations of dimensional analysis we have seen now, and the class is over. That's all for today, and hope that you are learning the physics smoothly. The classes are going on, and we are here. We are taking into account hard labor for you, and we are always for you. So please cooperate with us, because we are working hard for your welfare. So dear students, I am providing some homework to you. I will provide in PDF form some questions that you have to solve in homework, and today's class is over. Have a good day. Okay, thank you dear students.